We'll now take a look at the various components of SunRPC using an example. The client, again, will be contacting a server that can perform calculations, except this time the client will pass a single argument x, for which it will want the server to compute the squared value x squared. Here is the .x file for this example, with which the server specifies its interface. In the .x file, the server specifies all the data types that are needed for the arguments or the results of the procedures that it supports. In this case, the server supports one procedure, square_proc, that has one argument of the type square_in, and returns a result of the type square_out. The data types square_in and square_out are both defined in the .x file. If we take a look at them, it turns out that both of them have a single element, and that's an int. And in XDR, an int is an integer just like the integers in C. So it's a 32-bit integer. Also note that this notation _in_out is not any part of the required syntax for specifying the input and the output data types in XDR. Other than the data types, the .x file describes the actual RPC service and all of the procedure it supports. First, there is the name of the RPC service. In our case, that's square_proc. And this is the name that will be used by clients when they're trying to find an appropriate service to bind with. A single RPC server can support one or more procedures. For instance, a calculator server can support all sorts of arithmetic operations. In our case, the square_proc service supports exactly one procedure, and that's square_proc procedure. There is an ID number that's associated with it. This is 1 in this case. This number is not used by the programmer. This will be used internally by the RPC runtime when it's trying to identify which particular procedure is being called. So it's not going to pass between the client and the server in the packets the name square_proc. Instead, it will use this value 1 as a reference. In addition to this ID number and the input and output data types, each procedure is also identified by a version. And in fact, a version may apply to an entire collection of procedures. We see that in this case, the version number for a service is 1. Over time, however, we may choose to refine the square_proc procedure or add additional procedures. And as we're doing that, we don't want to be forced to immediately go ahead and update all of the clients with this perhaps semantically different or syntactically different square_proc procedure. In that case, what makes sense is that whenever clients and servers interact, they reference the version number of the procedure that they're requesting. When a client contacts a server that does not support a procedure with the appropriate version number, then the communication can be rejected. What this also illustrates is that it's possible for a single server to support multiple versions of the same procedure, and this helps with, in general, the evolution of the system. We don't have to coordinate an upgrade of all of the servers and all of the clients at the exact same time. Finally, the .x file also specifies service ID. This ID is a number that's used by the RPC runtime to differentiate among the different services. So the client will use things like service name and procedure name and the version number, whereas the RPC runtime will refer to the service ID, the procedure ID, and again, it has to know the version ID. For the service ID, you're allowed to specify a value in this range. The remaining values for service IDs either have some predefined values, like for instance for the network file system, or they're reserved for future use.